All right, number 5 on the review is our first foray into empirical probability instead of classical probability. Remember, classical probability is where every outcome is equally weighted. In other words, every outcome is equally likely. Flip a coin, getting heads or tails, equally likely. Drawing a card, the probability of drawing any individual card is the same as the probability of drawing any other individual card. Empirical probability, on the other hand, is based on data, experimentation. So when you're given some data that changes, not every event is necessarily, or every outcome is equally likely, so we have to consider what data we have. This problem reads, in a survey of college students, 878 say they have cheated on a test. So we have 878 say they have cheated. 1,711 say they have not cheated. If you are selecting a student at random, find the probability the student has cheated. So we want the probability, if we're selecting somebody at random, that that person cheated. Now, if this was a classical probability, it would be very simple. There's only 2 types of students, cheated and not cheated. If the probability of cheating and not cheating was equally likely, then it would be 1/2. There's 2 outcomes, 1/2, just like flipping a coin. But you can see from the data that the number of students that cheated is not the same as the number of students that not cheated. So that changes the probability and makes it an empirical probability problem. It's based on this data that we have. So the probability of cheated is the number of outcomes in the event, which is how many students cheated. That is right there. And that's divided by the number of students in the sample space. So we have to do a little bit of math here because the sample space is all the students that were surveyed. So some higher level addition here. Let's see, 9, 8, 5, 2. So our denominator is 2589, and the probability that you select someone at random and that person cheated is 878 over 2587, which should get you your answer, but let me look at it as a decimal. It's a little easier sometimes to get a feel for things when you can talk about them as a percent. People seem to understand that better. 2587. That's 0.339, or 33.9% of students cheated. So that would be the probability of selecting one student at random and getting one that cheated.